Now processing n jobs through 3 machines. This is the continuation of my lecture part 3. Now the characteristics of this type of problems are: first one, only 3 machines are involved in the process. Second, job is done only in the prescribed order, say M1, M2, M3. So first job should go to machine M1, secondly to M2, thirdly to M3. Third is no surpassing of jobs is permitted. That means passing of jobs is not permitted. Fourth is the actual processing time on each machine are given in advance or are known in advance. So these are the 4 characteristics of the problem processing n jobs through 3 machines. And the objective of this problem is find the optimal sequence. Find the optimal sequence of jobs. Optimal sequence of jobs which minimizes the elapsed time for completing the jobs, for completion of jobs. So the objective of this problem is find the optimal sequence of jobs which minimizes the total elapsed time for completing all the jobs. Here also we can apply Johnson's rule, but Johnson's rule can be applied only when one of the following conditions are satisfied, and that conditions are: first condition, the smallest processing time. The smallest processing time on machine M1 is greater than or equal to the largest processing time. Largest processing time on M2. That is the first condition. And the second condition is the smallest processing time on M3 is greater than or equal to the largest processing time on M2. So if either the first condition or the second condition or both the conditions are fulfilled, then we can apply Johnson's rule. So if either any one of the 2 conditions or both the conditions are satisfied, then to use Johnson's rule, first we have to convert the 3 machine problem to a 2 machine problem. That is done by taking another 2 hypothetical machines, say M4 and M5, where M4 is equal to M1 plus M2 and M5 is equal to M2 plus M3. Now, to apply Johnson's rule, we take the two machines as M4 and M5. Then the procedure is exactly same as that in the case of processing n jobs through two machines. Now, let us discuss one problem. Okay, this is the problem. Here we have three machines, M1, M2, M3 and 6 jobs, J1, J2, J3, J4, J5, J6. Now these are the processing time for each machine and for each jobs. Here all the numbers given are in days. So the time is given in days. So this is the problem. Here I have written jobs in the first row and machines in the column. You can write use the other method also. We can write J1, J2, the jobs here in column and machines M1, M2, M3 here. That is also possible. Now the hypothetical machines are M4 and M5. M4 is M1 plus M2 and M5 is M2 plus M3. Now M4, M1 plus M2, 8 plus 3, 11, 3 plus 4, 7, 7 plus 5, 12, 2 plus 2, 4, 5 plus 1, 6, 1 plus 6, 7. Then M5, M2 plus M3. So 3 plus 8, 11, 4 plus 7, 11, 5 plus 6, 11, 2 plus 9, 11, 1 plus 10, 11 and 9 plus 6, 15. Now we can apply Johnson's rule. So the optimal sequence is since there are 6 jobs, draw 6 cells 1, 2, 3, 4, 5, 6. Now search for the smallest number in the last 2 rows. Here 4 is the smallest number. Therefore, that 4 lies in the first hypothetical row. Therefore, the corresponding job J4 should be placed as first from left to right and at the same time delete that column. So you write J4 here. Now the next smallest number is this one, 6. 6 is coming in the first row, first hypothetical row. So the corresponding job J5 should write here and delete that column. Then the next smallest number is 7. 1 7 is here and next 7 is here. So do the jobs J2, J6 as in the order J2, J6 from right to left, or we can do the jobs in the order J6, J2 also. So cancel that 2 columns. Then the smallest number is 11. 1 11 is in the first row, the second 11 lies in the second row. So either we can put the corresponding job J1 here and corresponding to this 11 J3 here, or we can put the job J1 here, because 11 lies in the second row, so we can write J1 here, and the next 11 is also in the second row, so next to that J1 we can write the corresponding job J3 here. So the optimal sequence is J4, J5, J2, J6, J3, J1. Now the next procedure is to calculate the total elapsed time. For that we use the tabular method. So this is the table for calculating the total elapsed time. For that we need the time taken for each job at each machines also. So this is the question table. Using these values given in the question, we can fill the table. So this is the optimal sequence we obtained by applying Johnson's rule. J4, J5, J2, J6, J3, J1. Another possible optimal sequence is J4, J5, J2, J6, J1, J3. That is also correct. Now we have to find the elapsed time. For that we can use another table, that is known as a result table or conclusion table. The conclusion table is here. Okay, so this is the result table and this is the question and this is the optimal sequence. Both the sequence are correct. Here I am taking the first case, J4, J5, J2, J6, J1, J3. So write the sequence, job sequence here. Then construct 4 columns for machine M1 as time in, job time, time out, idle time. Similarly for machine M2 and also for machine M3. We have 3 machines. Now let us start to fill the cells. First, for machine M1, the first job is J4. So machine M1 is starting at 0th day and the job J4 at machine M1, job J4 at machine M1 is 2 days. So job time is 2 and therefore timeout is 0 plus 2, 2. Now after completing the first job in the second day itself the machine M1 is taking the second job J5. Now job time for J5 at machine M1 is 5. Therefore write that 5 here. So timeout is 2 plus 5. 7. Here there is no break. In the second day itself, machine M1 is taking second job, therefore idle time 0. Now in the 7th day itself, machine M1 takes the next job J2, therefore idle time 0. Now J2 takes 3 days at machine M1, so 3 days. Time out is 7 plus 3, 10, idle time 0. Now next 4th job is starting at 10th day, J6, 4th job is J6, the time is 1 day at machine M1, so 10 plus 1, 11, idle time 0, now 11 is writing here. Now J1 takes 8 days at machine M1, 11 plus 8, 9, idle time 0. And the last job J3 takes 7 days at machine M1. So 19 plus 7 is 26. Now after completing this much of cells, let us fill the cells for machine M2. Now machine M2 is starting the work at the first job, for the first job J4. But J4 is actually processing the work on machine M1 for first 2 days. So that 2 days machine M2 is free. So machine M2 is starting the work in the second day. So first 2 days machine M2 is free. Therefore the idle time is therefore 2. Now the job time for J4 at machine M2 is 2 days. So job time is 2. Or 2 plus 2, 4. So at the 4th day, machine M2 is free, but the second job J5 is completing only at the 7th day. So from 4th day to 7th day, machine M2 is free. So the difference 7 minus 4, 3 is the idle time for machine M2. Machine M2 can work only at the 7th day. Now starting the job J5. The working time of J5 is at machine M2 is 1. So 7 plus 1, 8. Now at the 8th day machine M2 is free, but here third job is completing at machine M1 only in the 10th day. So there is a gap in between 8th and 10th day. That gap is 2 days. So that 2 days is idle time for machine M2. Now machine M2 is starting the work at the 10th day for J2, job J2. J2 takes 4 days at machine M2. 4 days. So 10 plus 4, 14. Now at the 14th day itself, machine M2 can work on machine J6 because J6, the processing time or the process are completed in machine M1 at the 11th day itself. Therefore, at the 14th day itself, machine M2 can work on job J6. There is no gap in between these two numbers, therefore 0 is the idle time. Now the time for J6 is, at machine M2 is 6 days. So 14 plus 6, here it is 20. Now at the 19th day, next job is completing at machine M1. So in the 20th day itself, machine M2 can work on the job J1. J1 takes 3 days to complete the job at machine M2. So 20 plus 3, 23. But here there is no gap. So 0 is the idle time. Now in the 23rd day, machine M2 is free, but here the job J3 is completing only at 26th day. Therefore there is a gap in between 23rd and 26th. That gap is 3. So 3 is the idle time here. And in 26th day, the machine M2 is starting the work for machine job J3. And the J3 takes 5 days to complete the job at machine M2. So 26 plus 5, 31. Now let us fill the cells for machine M3. Here the first job is completing at machine M1 and machine M2 at the 4th day. So we should write time in of machine M3 is 4. So first 4 days is free for machine M3. So 4 is the idle time for machine M3. Now job J4 takes 9 days at machine M3. So 9 days. 4 plus 9 is 13. Now the second job is completing at 8th day itself. So we can start the job at the machine M3 on 13th day itself. And the second job is J5. The processing time for J5 at machine M3 is 10. So 13 plus 10, 23. So there is no gap. So idle time is 0. Now here it is 14. Therefore in the 23rd day itself, machine M3 can work on the third job J2. J2 takes 7 days. 23 plus 7, 30. There is no gap. Therefore, 0 idle time. Now next job, in the 30th day itself, the machine M3 can work on the next job, J6, because the 20th day itself, the work is completed. Now J6 takes 9 days at machine M3. 9 days. So 30 plus 9, 39. So there is no gap. Idle time is 0. Now in the 39th day itself, machine M3 can work on the next job. Here it is 23. Therefore, 39 plus the processing time of J1 at machine M3 is 8. So 39 plus 8, that is 47. And idle time is 0. Now here also, we can write 47 here because at the 31st day, this job is completed at machine M2. J3 takes 6 days, 47 plus 6, 53. Now, so the total elapsed time for completing the whole jobs is this number 53. This is the total elapsed time. And here the total idle time for M2 is 3 plus 2 plus 3 plus 2. That is 10. And the idle time for machine M1 is 53 minus 26. That is 27. Here there is one correction. This is not 3 actually. We should add some more days to 3. So 3 plus, actually after 31st day, machine M2 is totally free till 53th day. At machine M3, the job is completing in 53th day. But in machine M2, all the jobs are completed in 31st day. So from 31st day to 53th day, machine M2 is free. So we should add that much of days to here. So 53 minus 31, that is 22. So totally here it is 25 days. So total idle time is total idle time is 25 plus 2, 27, 30, 32. And here it is total 27. Here 4. So the final solution of the problem is the optimal sequence is J4, J5, J2, J6, J1, J3, and total time elapsed is 53, and idle time for M1 is 27, idle time for M2 is 32, and idle time for M3 is 4.